It wouldn't be a normal class if it didn't. Okay, log rule. Add makes it multiply. So log of 3x minus 2 times x minus 1. Remember, you can combine the sum of two logs. So if you're solving, condensing is helpful. It's less stuff to be, hey, exponents, put them back. Put it back. And this is for Malik. Now you can say no, just like you did that one time. That was weird. My 2-year-old, that's what he's into right now. But it sometimes comes with no, and this high-pitched crazy scream. It's okay, it's normal. 3x minus 2 times x minus 1. Do you notice something? That and that, the log of those two things, if we're going to make them equal, all we care about is what's inside the log to be equal. So it's one of these things called a 1-to-1 rule, or you guys can be super slick and you can go, hey, e to the power on both sides, e to the power on both sides, and cancel it that way. Same result. Firefox, had enough of you. Thank you. So you can do that. Now I'm going to solve what's left over. 3x minus 2, if I FOIL that out, I get 3x squared minus 3x minus 2x plus 2 equals x squared. FOILed this dude. Got that. And then we can combine that. So we got to solve this, don't we? What kind of problem is this going to be? Is this a quadratic? And then I'd say solve the quadratic. And we're going to stop there and let you guys solve the quadratic. Leave you that fun. Okay, we get two solutions. You check them to see if both work. Cannot take the log of a negative number. I do believe one of these is extraneous. So if you get a chance to come back and say, ooh, if one of them makes a negative number when I put it in for x inside my log, it's extraneous. Keep that in mind. So onward and upward, this is the one, just like we did before, and we had some recommendations from one of your mates. Divide both sides by 34. Oh, stop it. I'm talking to myself. 32. I didn't hit the random name generator. That's my problem. It was telling me I should have chosen one of you. 2 over 32. That looks interesting. We can mess with that. I like this problem for one reason and one reason only. We'll take the log of both sides, or should we do something different? We could do the log of both sides, and it would be just like this problem over here. We take the log of both sides, and we can multiply it out and divide it, and it'd be awesome. You can do that. For variety's sake, I'm going to convert this to the same base so you can see that's a possibility as well. I could make this 1 over 2 squared, or also 1/2 squared. That's also how we could do 1/4. And then that would be to the x over 3. You could do that. And then 2 over 32 is 2 over 32 to the 5th. 2 to the 1st. What am I talking about? It's 2 to the 5th is 32nd, is 32. This is 2 to the 1st. If you simplify that, that's 1 over 2 to the 4th, or 1/2 to the 4th. So we have 1/2 to the 2 times x over 3 equals, if I simplify this, 1 over 2 to the 4th, it's 1/2 to the 4th. If they have the same base, we could just compare those matching exponents. This is the alternative, which is equally valuable if you want to do it like we did before, which is, remember we divided by 20 on both sides per your recommendation. Check. And then we took the log of both sides. Check again. We pulled the exponent out front. Check. And then we solved for x by dividing and multiplying down here. Check. And got our result 6 with a calculator. You can also get things to the same base if you choose, like we've got here. So I made 2 into 2 to the 1st, 32 into 2 to the 5th, which is 1 over 2 to the 4th, and I made that 1/2 to the 4th. Now I've got same exponents that I can just simply solve. 2/3 x equals 4. And if I multiply both sides by 3 over 2, I get 4 times 3 over 2, 12 over 2, which is also 6. Huh. What a coincidence. Fun problem. But but done two ways. You are welcome to take the log of both sides and use your calculator, and that'll be there available to you. So now on this one, random generator says, how do I start this? Come on, number 5. Number 5 goes to, yes, Malik, what do you want to do first? Winner, winner, chicken dinner. Now think of what you want to do next, because it could be you. Feel free to do any method you want. 96 divided by 3 on my calculator says, I'll help you with that much, 32. Now, ready? Next, lovely soul, what do you want to do next? Jane.
What do you do next?
Yeah, what do you want to do next?
Okay.
Anything you want to do.
Can you do like x divided by 2 to the natural log of 4
Okay.
equals the natural log of 3.
So you can take the log of both sides? Love it. Works great. So we're going to take the log of both sides, pull the exponent outside. Great. That works. And then, do you mind if I do you want to do some algebra there? Divide by log of 4. And then times 2. Times 2 to cancel those. And that's your x, whatever you get from those. And you get 5? Okay, great. Now, if you want to do the same base thing, if you decide to go back to this square one part right there and decide to do same base, I will show you just off to the side here. This is 2 to the 2x over 2. 2 squared is the same as 4, right? 32 is 2 to the 5th, right? That seem okay? Let's check our answer. That's okay. Okay. 2 over 2 cancels, so it's just 2 to the x is 2 to the 5th. Hey, I get x equals 5 in that method too. Same thing you got with the calculator. So you can convert it to the same base. So if you don't have a calculator handy, your option is convert those to the same base and then compare your exponents. Same result, x equals 5. Cool, huh? All right, number 6. Somebody's got to start us. I think you know what to do. Look at 6 carefully. Here we go. And just keeping you alive. Andy's gone. Oh, dear, I better take attendance. I'm going to get a phone call. Okay. You want to take it on for her? Yes. Now we're getting superheroes. Yo. Okay, divide by 3. Divide by 3. So I get 5 to the negative x over 4 equals 5. Okay. Yo. And they're same, so I'll get 1, right? Okay, divide both sides by ln 5. Bam. Bam. So you get negative x over 4 equals 1. And should we just multiply out and go for a home run? X equals negative 4. Nice. Did anyone see early on the matching? Could we have just gone, oh, same base 5? Check this out. You could have just set those equal, got the same thing. So once you have the same bases, like having the same base log, you can just look at their innards and compare them that way. Nice. You're on. 7 and 8. Do you want to get a head start? You do 7 and 8 for just a second here while I do attendance and pause my recording. Can I pause or does it just stop? It just stops. That's okay.